Okay, so for 3.9, we're making generalizations. And basically what that means, generalizations is another word for predict, or predictions, or estimations, if that helps. The focus is going to be predict the size of a product relative to the size of one factor based on the size of the other factor. So you're going to be looking at the two numbers that you're multiplying, and you're going to make a generalization or a prediction about the answer based on how big or small they are. Okay. So if we need to pause right here for you to write this down, this might be good things for you. So first things we're going to do is we're going to predict how a product, that's the answer to a multiplication problem, will compare to one factor, which is one of the numbers being multiplied, based on the size of the other factor. So if you don't have this written down, you can go back tonight and look at it. But I want to make this so first thing I want you to think about is lesson 7. This is lesson 9, so I'm asking you to go 2 lessons back. We were comparing multiplication with whole numbers to multiplication with fractions. Do you remember that? And how an answer in a fraction is smaller and a product with whole numbers is greater. Okay. Suppose you multiply a whole number by w. So let's just do 3 times w. Okay. And w is another whole number. Will the product be greater than w or less than w? Greater. Because you're going to be combining more than one copy. You're going to be having 3 copies of this, right? 3 times this number, right? Okay. So then if I'm doing a fraction, like a over b, if you multiply a fraction ab that is less than 1 by another fraction less than 1, so this is going to be less than 1 equals, the product will be greater than or less than a over b. Less than, because you're taking a part of that fraction. So like half of 3/4. So the answer is going to be smaller than 3/4 because you're taking part of it. We're going to use this knowledge today in our predictions, okay? This was just kind of a review from 7. In order to make those predictions, we have to have that understanding and that vocabulary, okay? So let's look at 3/4. 2/5 times 3/4. I'm looking at number 1 here. 2/5 of 3/4. Is that answer going to be greater than or less than to 3/4? I'm hearing less than, which would be right, because we know you're taking 2/5 of 3/4, which means it's going to be smaller than 3/4. So what's the real answer? You have 6/20, but what's the real answer? 3/10. Is that smaller than 3/4? Yes, because it's a piece of 3/4. So let's look at, 6/6 of 3/4. What is that going to equal? Greater than, less than, or equal to? Equal to. Why do you think it's equal to? You're talking about one whole. You're talking about one whole of 3/4, which is going to be, if you're talking about the whole 3/4, what is it? 3/4. But do the multiplication anyway. 18/24 divided by 3. 6 equals 3/4. All right. We got one with a whole number. You ready? 1 3/7 of 3/4. Is it going to be greater than or less than 3/4? So you're taking 1 whole and 3/7 of 3/4. Is the answer going to be greater than or less than? Ask your partner. Talk to your partner. If you guess greater than, you would be correct. Because taking what we already know, you're taking some and then some. Right? If you're multiplying. So if you're multiplying this, first things you have to do is make this what? Improper fraction, which is 10 sevenths times 3/4, which equals 30 28ths, which equals 1 and 2 28ths, which equals 1 and 1 14th. This should be 28ths, sorry. 14ths. 1 and 1/14. It's more than 3/4. You were correct. Nope, we're talking about this factor. Okay. All right, now let's look at number 4. Now you're predicting 3 threes. Right here, I'm looking at this one. 3 threes of 2.5. First of all, what is 3/3? 1 whole. I hope you're writing all of these examples down. I see some of you with your pencils not moving. Would you predict that it's going to be greater than, less than, or equal to 2.5? What would you predict? We're taking 1 whole of 2.5. How many think less than? How many think equal to? How many think greater than? Well, nobody thinks greater than. That's good. It's actual equal to. If you're taking 1 whole 3 threes of 2.5, you're going to get 2.5. But I want you to see how that works out in the algorithm. 5/2 multiplied 3 threes is 15 sixes, yes. 6 goes into 15 2 times with 3 6 remaining, which is 2 and 1/2. Isn't that crazy how that works out? Now predict this. 2 2/3 of 2.5. No, take what you know about greater than and less than, and is the product going to be greater than or less than 2.5? What do you think? What do you think? What do you think? Think. Nobody has a guess? Grant Johnson. Greater than. Why do you think that? Look at those fractions. What do we know about those fractions? 2/3 is greater than or less than 1/2? Greater than. So our product is going to be greater than. And if we do the math, 6, 7, 8 thirds times 4, 5 twos equals 40 sixes. 6 goes into 40 how many times? 6 with 4 6 remaining, which is way more, right? Now, let's look at this one. 7/8 of 2.5. Is the product going to be greater than, less than, or equal to? Based on what we already know and what we've already experienced. Turn to your neighbor and tell them what you think. Good job. Your product, X, is going to be less than 2.5 because you're saying a piece of the 2.5, not above 2.5, a piece of it. So if I was doing this one, 4, 5, 7/8 times 5/2, what do I get? 35/16. How many times does 16 go into 35? 2. with 3 remaining. So 2 and 3/16, which is definitely smaller than 2.5. Okay? I think you're starting to get it. Can you try 7, 8, and 9 in your notebook by yourself? Make a prediction. X is greater than or less than to the product that it's giving you. Ooh, this one gets a little tricky too. Is the product going to be greater than or less than that? It's kind of backwards what we've been doing. But I want to see if you can take what we know and apply it. So go ahead and try it. Okay, so we just had a realization that 11/10, which is 1 1/10 improper, times 5 is actually 5/1. It's not 5/5. If you did 5/5, that is 1. It's not 5. Because this right here is actually saying 5 divided by 1. What is 5 divided by 1? 5. That's what you need. So you have 55/10, which equals 5 5/10, which equals 5.5, which is bigger. Okay, so the whole point of this is being able to look at your factors and start to see the patterns, to start to see if it's a whole number, like this, like number 7, if it's a mixed number like number 4, or if it's a fraction like number 1. Okay? So like I said, these 3 sentences need to kind of be in your back of your mind so that you can attack these word problems with more confidence. Okay? So if I were looking at a box of granola weighs 18 ounces. A box of cornflakes weighs 7/9 as much as the granola. Do the cornflakes weigh more or less than 18 ounces? Well, 7/9 as much. So what is the problem that we're looking at? It is a multiplication problem, but set it up for me. What should it be? 7/9 of 18 equals what? Is it going to be greater than or less than 18? Less than. Very good. So how much does the cornflakes weigh? Well, you're going to do 7/9 times 18/1. And like I said, just because I'm a creature of habit, and I hate to reduce, how much does my box of cornflakes weigh? 14 what? 14. Is the area of the rectangle greater than or less than 1 3/4? So it's length times width, right? So 3 1/4 times 1 1/3 equals what? Is that going to be greater than or less than 3 1/4? This is another example of like what Timothy was telling us. He could see that 3 times 1 is going to be 3, but he also knows that we also have to multiply this. So it's going to be greater than 3 1/4. He knows that. You know that. So if I were switching these, so it should look like this. 4 1/3 is definitely greater than 3 1/4. So it's one of those things that even if it doesn't ask you to predict, you can already kind of go, okay, I know my answer needs to be bigger than this factor. It's kind of one of those checks and balances type thing. So it's really important. Here are the answers and the problems for 18 and 19. You got to look at the words of what it says. If it says 9/10 this far, that's a little piece of the other number. Or 1 3/4 times, it's exactly what you're supposed to do. So tonight for homework, you're going to be doing Think Central, and you're going to be making some of these generalizations, and it will help you to have those sentences that you know, like when one factor is the other factor.